Why massive ships have flat bottoms. Have you ever looked at one of the world's largest cargo ships and wondered why it seems to have such a flat bottom? At first glance, it doesn't make much sense. We usually associate speed and efficiency with sleek, pointed designs. Airplanes have streamlined wings, sports cars have aerodynamic bodies, and even speedboats use sharp V-shaped hulls to slice through the water. So why would engineers build a vessel weighing hundreds of thousands of tons with a hull that looks almost flat? The answer is surprisingly simple, but it involves some fascinating engineering. First, it's important to understand that not all ships are built for the same purpose. A military destroyer needs speed and agility. A racing yacht is designed to cut through waves with as little resistance as possible. But a container ship has one primary mission: carrying as much cargo as possible while using the least amount of fuel. Every additional shipping container represents more revenue. That means engineers are constantly searching for ways to maximize the usable space inside the ship, without making it unnecessarily larger. A flatter hull provides much more internal volume than a narrow V-shaped design. Instead of wasting space in a deep, pointed bottom, engineers create a wide structure that can hold thousands of containers stacked both below and above the deck. But cargo capacity is only part of the story. A flat-bottomed hull also improves stability. According to Archimedes' principle, a floating object displaces an amount of water equal to its own weight. By spreading the ship's weight across a much wider area, the vessel becomes more stable in the water. This is incredibly important because modern container ships often carry over 20,000 containers. Imagine stacking thousands of heavy metal boxes several stories high. If the ship rolled too much in rough seas, the cargo could shift, damaging containers or even threatening the safety of the entire vessel. A wider, flatter hull helps reduce that rolling motion. It creates a stable platform capable of safely transporting enormous loads across oceans for weeks at a time. Another major advantage is something called draft. Draft is the distance between the waterline and the bottom of the ship. In simple terms, it tells you how deep the ship sits in the water. A ship with a very deep hull requires deep ports and waterways. That creates a huge limitation, because not every harbor is capable of handling extremely deep vessels. By designing the hull with a flatter bottom, engineers reduce the draft while still maintaining an enormous carrying capacity. This allows these giant ships to enter more ports around the world and travel through important trade routes where water depth is limited. However, this design is far from perfect. Flat-bottomed ships are not particularly fast. They also perform poorly in rough seas compared to ships with deeper, more streamlined hulls. When large waves strike a flat surface underneath the ship, the impact can be extremely powerful. Engineers call this phenomenon hull slamming, and it places significant stress on the structure. This is one reason why naval vessels, cruise ships, and high-speed ferries use completely different hull designs. Their priorities include speed, passenger comfort, maneuverability, and handling in rough weather. Cargo ships simply have different priorities. For them, efficiency matters far more than speed. In fact, many of the world's largest container ships travel at only around 18 to 22 knots. They could go faster, but doing so would dramatically increase fuel consumption. By maintaining moderate speeds and using wide, efficient hulls, shipping companies save millions of dollars every year while reducing emissions. The shape of the hull also helps distribute the tremendous weight of the cargo more evenly across the ship's structure. This reduces stress on the steel frame and increases the vessel's overall durability. During long voyages across the world's oceans, modern ship design is actually the result of decades of computer simulations, scale model testing, and real-world engineering experience. Every curve, every angle, and every measurement is carefully optimized to balance cargo capacity, stability, fuel efficiency, structural strength, and operational costs. So the next time you see one of these enormous ships crossing the ocean, remember that its flat bottom isn't a shortcut or a compromise. It's one of the smartest engineering decisions ever made. That seemingly simple design allows the ship to carry more cargo, stay stable in the water, reach more ports around the world, consume less fuel, and keep global trade moving every single day. Sometimes the most brilliant engineering doesn't look flashy or futuristic. Sometimes it's simply the design that solves the greatest number of problems at once. And that's exactly why so many of the world's biggest ships have flat bottoms.